Hello everyone. In this video, we're going to be dealing with a system of equations. We have 5x plus 2y plus 8z equals 5 and 2x plus 3y plus z is equal to 13. So those two equations are given and we're supposed to evaluate x plus y plus z. Now, this is not a Diophantine system, so x, y, z do not have to be integers. But how do you solve an equation, a system of equations with three variables when you only have two equations, right? That is the $1,000,000 question. I'm also going to show you something graphical towards the end. You can basically graph these in 3D, thanks to Desmos. They didn't have the 3D. I don't know why they didn't have it for such a long time, but now you can do 3D things. Okay? Great, so let's go ahead and look at this problem from different perspectives. I'm going to start with the first method. And for my first method, basically, I'm going to try to solve for one of the variables, at least, right? So let's see. There's actually different approaches that we can apply here. And one of them is basically taking these two equations, right? I can try to solve for x from both of these equations. But how is that going to help? I can kind of set them equal to each other. And then using that information, maybe I'll get something between y and z. But I think a better idea is probably, I would say, just thought of this, by the way. Let's write the equation like this. 5x plus 2y equals 5 minus 8z. And then the other equation, basically what I'm doing is writing this as a system of x and y, two variables, and just treat the z as a constant. That kind of works, right? If we knew the value of z, we could easily solve for x and y. So that could also be another approach which we might have used, right, later on. But let's go ahead and stick to this first. So notice that we have now two equations with two variables if you ignore the fact that z is a variable. So let's go ahead and solve for x and y. Now, if you get a system of equations like this, what would you do to solve it? Which method would you use? Elimination, substitution? I think elimination would work well here. Maybe we can just go ahead and try to eliminate y. Let's multiply the top equation, let's call that first, by 3. That will give us 6y, and I want y to cancel out, so I'm going to multiply the second equation by -2. Normally, I would continue like this, but if you don't have room, you can also write it underneath here. So we're going to get 15x plus 6y is equal to, make sure to distribute to 3, give you that, and then distribute to -2, okay? And then that'll give you -6y, and that should equal -26 plus 2z. And now we're going to go ahead and add these two to eliminate y. That'll give us 11x equals, now let's go ahead and see if we can simplify this, -22z minus 11. Wow, isn't that amazing? Everything is divisible by 11. Beautiful, right? Of course, that's not a coincidence. Divide everything by 11. That's going to give you -2z, or not 2z. Did that work? -1. And of course, since I'm dividing by 11, that should be 1x. There you go. We were able to get x in terms of z. You know what that means? Since our system is a system of equations of x and y, there is two variables. We can go ahead and substitute it to find the value of y in terms of z. Let's just use the second equation. 2x plus 3y is equal to 13 minus z. Now I'm going to go ahead and replace x with this. That'll give me -4z minus 2 plus 3y equals 13 minus z. Again, our goal is to solve for y. Let's go ahead and put the z on the other side. That'll be a plus 4z, which will give us 3z, and then -2 plus 2, 13 plus 2 is going to be 15. And ta-da, again, everything is divisible by 3. So from here, we're going to get y equals z plus 5. Awesome. Now, what we did was actually significant because we were able to write x and y both in terms of z, which is at this point considered a constant, right? So what can we do now? And wait a minute, what are they asking for, right? What is the problem asking for? By the way, this could be considered a homemade problem, so I'm like, what am I asking for, right? We're asking for x plus y plus z. So how do you find it? Well, just substituting, because we do know that x and y is expressed in terms of z. So does that mean the answer is going to be in terms of z? Let's find out. So I'm going to go ahead and replace x with negative 2z minus 1, which is x. And then replace the y with z plus 5. And replace z with what? Replace z with z because z is z, right? Obviously. Now everything is in terms of z, and guess what happens? Z plus z is 2z. Again, 2z or not 2z, that is the problem. And we end up with a constant. Isn't that beautiful? So the answer would be 4 in this case. In other words, x plus y plus z is equal to 4 based upon the two equations that I gave you. Wait a minute, what is that supposed to mean? Okay, again, I'll show you the graphics. You'll hopefully get an idea about what it looks like, and you can do this for yourself too. But notice that x plus y plus z happens to be a constant. That was the goal. That's why I kind of came up with this problem. And let's go ahead and use a second approach. So given the first method, you probably realize that it doesn't matter how I express x and y, x plus y plus z is always a constant, right? What is that supposed to mean? It means that you can assume values for x, y, or z. Not all three at the same time, because you got to make sure both of these equations are satisfied. Well, can we pick z and y then? I think so. Why not? I don't see a problem with that. Let's go ahead and test it out. What if y is equal to 0 and z is equal to 0? Would that work? Let's test it out. If y and z are both 0, then we're going to get 5x equals 5 and 2x equals 13. Uh-oh, Houston, we have a problem. Inconsistency, right? Obviously, you can pick values for two of the variables because then you would end up with a single variable which may or may not work. So you're only going to use a single variable numerically. So let's just say, okay, I think z equals 0 seems to be a good one. But if you want to change things up a little bit, let's go with x equals 0. Because you know why? If you use z equals 0, you're going to get a similar system that you solved before. But let's change things up a little bit. If x is 0, again, the fact that the answer is a constant and can be found by any method means that the values of x, y, z don't really matter as long as the two equations are correct. Now, what does this tell you? This gives you another system, and again, eliminating wouldn't be too hard. I don't know if you like the negatives. I don't, but it's okay. We're just going to multiply this by negative 8, and that'll do the work. And from here, we get 2y plus 8z equals 5. The top one stays the same, and this becomes negative 24y minus 8z is equal to 8 times 13 is 80 plus 24, which is 104, but that's a negative 104. And now we're going to go ahead and add these up. That's going to give us negative 22y is equal to negative 99. Wait a minute, is that true? I think so. Yeah, that seems to be true to me. Now, we didn't get a nice value for y, but that's perfectly fine. If we divide both sides by negative 22, I think you can divide everything by 11. You're going to get 9/2, which is 4.5. Great. So x is 0, y is 4.5. What about z? Well, to find z, you just have to plug it in. Let's use this equation, or second one is even better. 3y plus z is 13. We know that y is equal to 4.5. So this is going to be 13.5 plus z is equal to 13. From here, z is equal to negative 0.5. So let's go ahead and put it all together. I was going to say like y is equal to 4.5. X is equal to 0. And if you go ahead and add these up with a big plus sign, then from here, you get x plus y plus z is equal to 4, because 4.5 minus 0.5 is 4. Make sense? We got the same answer. Yay, that's good. Now let's go ahead and take a look at the third method, because I think the third method is my favorite, and that's actually how I came up with this problem. So I'm going to give you a secret here, and you can do the same. Please do, and let me know if you can find a system that works like this. And let's not forget that we're going to look at the graph of something at the end, okay? So here's the whole idea. Now, we should be able to find x plus y plus z from these two equations. In other words, if you think of in terms of vectors, it should be a linear combination of these two things. What is that supposed to mean? It just means that, okay, I should be able to multiply the first equation by a. I should probably use a different color, like this maybe. I don't know. Okay, white. Let's just say I multiply everything by a and multiply everything by b, and then add the results, and I should be able to get x plus y plus z. How is that possible? Let's go ahead and take a look. This gives me 5ax plus 2ay plus 8az equals 5a, and then this gives me 2bx plus 3by plus bz. By the way, let me just tell you that this wasn't easy to come up with because you have to make sure that the numbers work. And you'll see now how that works. Now, when you add these two things, you're going to get 5a plus 2b as the coefficient of x, and then 2a plus 3b as the coefficient of y, and then 8a plus b as the coefficient of z. And of course, the result will be 5a plus 13b. The right-hand side is not that important, but take a look at the left-hand side. From here, you want x plus y plus z, which means the coefficient of x, y, and z, they all have to be equal. What is that supposed to mean? It means that 5a plus 2b is equal to 2a plus 3b, and that's equal to 8a plus b, right? So, how is that possible? Let's take a look at these two first. This means 3a is equal to b. Awesome. So from this, we get that. How about this one? This gives you 6a is equal to 2b, which is the same as 3a is equal to b. So as long as you pick a and b in such a way that b is 3 times a, then you'll be fine. Now, what is that supposed to mean? Let me rewrite the problem, and I'll explain what I mean by that. This is really cool, and there's probably a geometrical interpretation which you can let us know if you are good at geometry, 3D geometry, because this definitely has a meaning. Now, here's what it means. Now, remember, I multiplied this by a and this by b, and I just found out that, okay, b is supposed to be 3 times a. So whatever I pick for b, let's just pick 1 for b. B is 3 times a, right? So let's say we pick 1 for a, which means we're not really multiplying. Then b can be 3. Let's see what happens after we do this. We get 5x plus 2y. The top equation stays the same. And then the bottom one will be tripled. You're going to get something like this. And ta-da-da-da, this is where the magic or the mathemagic begins. When you add these things, you're going to get 11x plus 11y plus 11z. Not only that, on the right-hand side, you're also going to get a multiple of 11, which is really cool because if you factor out an 11 here, then you can just divide both sides by 11 and find that x plus y plus z is equal to 4 as before, right? And this almost brings us to the end, but I got to show you, like I promised earlier, the 3D thing, right? Are you ready to see the facts? Ta-da-da-da. As you can see here with the 3D Desmos, you can just type up desmos.com/3D. By the way, this video is not sponsored by Desmos. I wish they did sponsor. Maybe they will one day, who knows. But anyways, you get the idea. This is a 3D graph, and these are planes. And guess what their intersection looks like? Another plane, which is given by the equation. And you're going to find out which that equation is, right? So this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out SyberMath, the Shorts channel, and the aplusbi, which is a channel that focuses on complex numbers. And until next time, bye-bye.